All right, I'm going to take a couple minutes to go over a review worksheet. This is something that you learned in definitely geometry, possibly in Algebra 1. So I just wanted to take some time to go over it. So when we simplify radicals, what we are looking for is we're looking for perfect squares. So it's best always to make this list at the top of your paper or somewhere that's handy to look at. So perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Okay, so that is the start of our list. Now, how did I come up with these numbers? If I take 1 and multiply by itself, I get 1. If I take 2 and multiply by itself, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Okay, these are numbers that we can take the square root of. Square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. Now, since I can take the square root of these, there is a property, and it says that if I were to take the square root of a number, scroll this back up. If I take the square root of a times b, this is the same thing as the square root of a times the square root of b. So what I want to do is I want to try to break these. Now, you have to be very careful. This is only for multiplication. It does not work for addition. I can show you a counter example of how this doesn't work. If I said the square root of 25 is 5, and then I said, okay, is it the square root of 20 plus the square root of 5? Well, the square root of 20, if I do this on a calculator, it's some funky decimal like 4.47, plus the square root of 5 is 2.23, which I can definitely see is going to be more than 5, so that does not work. Okay, so it only works for multiplication. So, knowing that, what we want to do down here is break up these numbers into things that multiply. So, for example, I want to find the largest perfect square that goes into 75. What I'm going to write it as the square root of 25 times the square root of 3. Because if I have the square root of 25 times the square root of 3, I can take the square root of 25. My answer is 5 times the square root of 3. Now, you don't have to write that multiplication sign in there, so it's just 5 square roots of 3 is your final answer. Now, the square root of 16, that one, the largest perfect square that goes into 16, is 16. So this answer is just 4. So moving back down to something like the square root of 80, because this one you should get just a number 4. That one you should just get a number 4 because they're on our list. The square root of 80, find the largest perfect square that goes into 80. Now let's say you don't find the largest one. We'll do that we can do that with this one. Okay, so let's say we said 4 goes into 80. So this would be the square root of 4 times 20. 4 times 20 is 80. Okay, then my answer I get is 2 square roots of 20, which technically is not correct because 20 has another perfect square that goes into it. So let's keep going. We still have the 2 on the outside, but the square root of 20 breaks down into the square root of 4 times the square root of 5. Now the square root of 4 turns into 2. So we have 2 times 2 times the square root of 5. 2 times 2 is 4 square roots of 5. That would be your final answer. Now, the reason why I mentioned the largest perfect square is if you took the square root of 80 and said, okay, 16 is larger than 4, it's on our list, and it also goes into 80. So square root of 16 times the square root of 5. Square root of 16 is 4 square roots of 5, and you would get there in a lot less steps. So if you're finding the largest perfect square, that's going to be much easier than if you find a smaller perfect square and then notice, well, 20 still has another perfect square to go into it. So you'd have to break it down again. So this is your best bet, is to always go with the largest perfect square. Yes, you can do it this way, but it's just going to be in more steps. That's how you're going to do this first page. So I will let you go through and work on this. and then I'll upload a second video for how to multiply and divide. So that is just with the simplifying. Some people like the factor tree method, so I can show that to you as well. So the square root of 80 is what we did. Some people use the factor tree method, and so what they're going to do is they break this down and they say, okay, 40 times 2. This breaks down into 20 times 2. This stays a 2. This breaks down into 10 times 2. I still have the 2. I still have the 2. This breaks down into 5 times 2. I still have this 2. I still have this 2. And I still have this 2. If you have 2 of them, they go on the outside. So you'd have 2 and 2. But they only go on the outside as 1 because when you square root them, it undoes the doubling and it makes it as 1. So the 5 is left on the inside. So you'd write this as square root of 5. You'd have 2 times 2 on the outside, which is 4 square roots of 5. So some people like to do it this way. I have never been a fan of this way, the factor tree method. If you're comfortable with that, that's totally fine. It might get a little bit tricky once we get into complex numbers, which is what we are doing later today once you guys do this review activity.